Now let's solve this question. The question is sum of all real solutions of the inequality. So there is an inequality given and we need to find the sum of all the real solutions. First we need to solve the inequality, and whatever value we get in from this inequality, we need to add all the inequality. We need to add all the value of x. Okay. So let's solve the question. The question is x square plus 2 x square minus 16 x to the power 4 plus 2 x square minus 9 less than equal to 0. Okay. Now one point I would like to tell here that if you find any expression which is always positive, which is always positive, if you find any expression which is always positive, like this x square plus 2 and x to the power 4, this is always positive. Whatever value you take of x, you will find that this expression can never be negative. So this is always positive quantity, always positive. This also always positive. Okay. So let me tell you one thing here. If you find any expression which is always positive, that means you can simply, delete this portion from this inequality. You can simply, delete this portion from the inequality. Okay. And okay, one more thing here. This portion is also positive. This portion is also positive. Like you must be knowing that square root of something, square root of something, the value we get is always positive. The result of a square root is always positive. You should know that. Okay. So, but here the square root is there, so domain will be defined. You need to define the domain first. Okay. So okay, let's do the domain part later, and let's solve the inequality first. Let's solve the inequality first. Okay. So this part is positive. All the positive parts. This is also positive. All the positive parts I am deleting from the inequality. Okay. So the only part is remaining is x square minus 9 in the denominator. So x plus 3 and x minus 3 less than equal to 0. Less than equal to 0. So here the critical points are, the critical point will be, critical point is 3 and minus 3. Critical point is 3 and minus 3. Okay. So let's plot the critical point in a number line. Minus 3, 3. So it will be positive, negative, and again positive. And the answer is asking is negative. So minus 3 to minus 3 will be open and 3 will also be open, because at minus 3 and 3 the denominator is going to 0. So that means that will make the whole expression is undefined. Okay. So that's why 3 and minus 3 is excluded from the answer. Okay. Now can you consider this answer as a final answer? The answer is no. This is not the final answer. Why? Because we have cancelled this part, the square root part, because we know that square is always positive. But whenever you see any square root expression, you need to always define the expression that is there inside the root. The part which is there inside the root or square root, you need to define that part. Okay. So for that, what we will do, we know that if there is any expression inside the square root, then that expression should be positive. So x square minus 16 should be positive, or it can be 0 also. Yes. So x plus 4 and x minus 4 greater than equal to 0. So let's plot in the number line minus 4, 4, positive, negative, positive. So from here the answer is, the solution is minus infinity to 4, minus 4 and 4 to infinity. Minus infinity to minus 4 and 4 to infinity. Okay. So now what we need to do? We need to take the intersection of both the solution. We need to take intersection of both the solution. Let's take intersection. Let's take intersections. So let's plot all the critical point in one number line. Minus 4, minus 3, 3 and plus 4. So the one result is the first part, this, let's say this is first part, this is second part, the domain part. So the first part result is minus 3 to minus 3 to 3, and the second part result is minus infinity to minus 4, minus infinity to minus 4, and 4 to infinity. So what is the common part between the two solutions? Is there any common part? No, there is no such common part. So the answer will be, here is x belongs to 5. X belongs to 5. So there is no such values of x exist for this solution. Okay. So if this is the case, then what should be the answer? Here the question is saying sum of all real solutions. Sum of all real solutions of the inequality. That means we have found that there is no real value of x exists. So that means the answer is D. That means the answer is D.